The scientific revolution. From the earliest times, people have been curious about the world around them. Thousands of years ago, people began to use numbers, study the stars and planets, and watch the growth of these plants and animals. These activities were the beginnings of science. Science is an organized study of the natural world and how it works. Early scientists. Early civilizations developed kinds of science to solve practical problems. Among the first sciences were mathematics, astronomy, and medicine. Mathematics was used for record keeping and building projects. Astronomy helped people keep time and figure out when to plant and harvest crops. Early civilizations also developed medical practices such as surgery, acupuncture, and the use of herbs for treating illnesses. The ancient Greeks left behind a large amount of scientific knowledge. They believed that reason was the only way to understand nature. As they had understood the world, they developed theories. A theory is an explanation of how something happens. A theory is based on what you can observe about something that may not be correct, but it seems to fit the facts. In ancient Greece, the Greek philosopher Aristotle observed nature and collected vast amounts of information about plants and animals. He took the facts he gathered and classified or arranged them into groups based on similarities and differences. The Greeks made many important scientific advances, but their approach to science had some problems. For example, they did not use experiments or test new ideas to see if they were true. Many of their conclusions were false because they were based on common sense instead of experiments. For example, in AD 100, the Egyptian-born astronomer Ptolemy stated that the sun and planets moved around the Earth in circular orbits. After all, it did seem like the Earth was at the center of the universe. Astronomers in Europe accepted Ptolemy's geocentric or Earth-centered theories for more than 1400 years. Science during the Middle Ages. In Roman times, most people continued to accept the scientific knowledge of the Greeks. After the fall of Rome during the Middle Ages, most people were more interested in theology, the study of God, than the study of nature. For scientific knowledge, they relied on Greek and Roman writings and saw no need to check their facts to make sure their own observations. Many of these ancient works, however, were either lost or poorly preserved. In the writings that did survive, errors were added as copies were made. Meanwhile, Arabs and Jews in the Islamic Empire preserved much of the science of the Greeks and Romans. They carefully copied many Greek and Roman works into the Arabic language. They also came into contact with science of the Persians and Indian systems of mathematics. The Arabic and Jewish scientists made advances of their own in areas such as mathematics, astronomy, and medicine. However, in spite of these achievements, scientists in the Islamic world did not experiment or develop the instruments necessary to advance their scientific knowledge. During the 1100s, European thinkers became interested in science again as a result of their contact with the Islamic world. More Islamic scientific works were brought into Europe and translated into Latin. The Hindu-Arabic system of numbers also spread into Europe, where it eventually replaced the Roman numerals. Christian thinkers such as Thomas Aquinas tried to show that Christianity and reason could go together. During the 1100s, Europeans began building new universities. They would play an important role in the growth of science. Beginning in the 1400s, voyages of exploration further added to the European scientific knowledge. Better charts, maps, and navigational instruments helped the voyagers reach different parts of the world. Through exploration, the science of oceans and continents became better known. Scientists gathered and classified new knowledge about plants, animals, and diseases in different parts of the world. As scientific knowledge grew, the stage was set for new understandings of the natural world that would shake Europe to its foundations. During the 1400s, European thinkers began to break with old scientific ideas. They increasingly understood that advances in science could only come through mathematics and experimentation. This new way of thinking led to a revolution or sweeping change in the way Europeans understood science and the search for knowledge. Astronomy was the first science affected by the scientific revolution. new discoveries brought changes in the way Europeans saw the universe. They challenged traditional thinking that God had made the earth as the center of the universe. Who was Copernicus? Leading the scientific revolution was a Polish mathematician named Nicholas Copernicus. In 1543, Copernicus wrote a book called On the Revolution of the Heavenly Spheres. He disagreed with Ptolemy's view that the earth was at the center of the universe. Copernicus believed that Ptolemy's theory was too complicated. Instead, he developed a heliocentric or sun-centered theory of the universe. Copernicus' theory stated that the sun, not the earth, was the center of the universe. The planets moved in circular paths around the sun. Kepler's revolution. The next step in the march of science was taken by a German astronomer named Johannes Kepler. He supported Copernicus' theory, but also made corrections to it. Kepler added the idea that the planets moved in ellipses or oval paths rather than circular ones. His theory made it easier to explain the movement of the planets, and it also marked the beginning of modern astronomy. Who was Galileo? An Italian scientist, Galileo Galilei, made the third great breakthrough in the scientific revolution. Galileo believed that the new knowledge could come through experiments that were carefully carried out. For example, Galileo challenged Aristotle's idea that the heavier the object is, the faster it falls to the ground. Galileo's experiments proved that Aristotle was wrong. Objects fall at the same speed regardless of their weight. Galileo also realized that the scientific instruments could help humans explore the natural world. He improved instruments such as a clock and telescope. With the telescope, he found clear evidence supporting Copernicus' view that the earth revolved around the sun. Galileo played an important role in the development of new scientific instruments. In 1593, he invented a water thermometer that, for the first time, allowed temperature changes to be measured. Galileo's assistant, Evangelista Torricelli, then used an element called mercury to build the first barometer, an instrument that measured air pressure. When Galileo published his ideas in 1632, his work was condemned by the Roman Catholic Church. The Catholic Church held to the geocentric or earth-centered view of the universe, believing that it was taught in the Bible. The Pope ordered Galileo to come to Rome to be tried for heresy. Church threats finally forced Galileo to withdraw many of his statements. Even so, Galileo's ideas spread throughout Europe and changed people's view of the universe. Throughout the 1600s, the scientific revolution continued to spread. Many new discoveries were made in physics, medicine, and chemistry. Who was Isaac Newton? Despite continuing the scientific breakthroughs, the ideas of Copernicus, Kepler, and Galileo need to be brought together as one system. This feat was accomplished by English mathematician Isaac Newton. According to tradition, Isaac Newton was sitting in the garden one day when he watched an apple fall to the ground. The fall led him to the idea of gravity, or the pull of the earth and other bodies on objects near the surface. In a book called Principia, he published in 1687, Newton stated that his laws are well-tested theories about the motion of objects in space and Earth. The most important was the universal law of gravitation. It explains that the force of gravity holds the entire solar system together by keeping the sun and the planets in their orbits. Newton's ideas led to the rise of modern physics and the study of physical properties such as matter and energy. Medicine and chemistry. Sweeping changes were made in medicine in the 15 and 1600s. Since Roman times, European doctors have relied on the teachings of the Greek physician Galen. Galen wanted to study the human body, but was only allowed to dissect or cut open animals. In the 1500s, however, Flemish doctor Andreas Vesalius began dissecting dead human bodies for research. In 1543, Vesalius published On the Structure of the Human Body. In this work, Vesalius presented a detailed account of the human body that replaced many of Galen's ideas. Other breakthroughs in medicine took place. In the 1600s, William Henry, an English doctor, proved that blood flowed through the human body. In the 1600s, an English scientist named Robert Hooke began using a microscope, which as soon as he discovered cells, soon he discovered cells, the smallest structures of living material. Wow. Beginning in the 1600s, European scientists developed new ideas in chemistry. Chemistry is the study of natural substances and how they change. In the 1600s, Robert Boyle, an Irish scientist, proved that all substances were made of basic elements that cannot be broken down. European scientists of the 1700s also developed ways to study gases. They discovered hydrogen, carbon dioxide, and oxygen. In 1777, Antoine Lavoisier of France had proven that materials needed oxygen to burn. Marie Lavoisier, also a scientist, contributed to her husband's work. The triumph of reason. As scientists made new discoveries, European thinkers began to apply science to society. For these thinkers, science had proven that the physical universe followed natural laws. By using their reason, people could learn how the universe worked. Using this knowledge, people also could solve existing human problems and make life better. Descartes and reason. One of the most important scientific thinkers was that of Frenchman René Descartes. In 1637, he wrote a book called Discourse on Method. In this book, Descartes begins with the problem of knowing what is true. To find truth, he decided to put everything that he had learned and make a fresh start. To put aside everything he learned and make a fresh start. To Descartes, one of the facts seemed to be beyond doubt, his own existence. Descartes summarized the idea in the phrase, "I think, therefore I am." In his work, Descartes claimed that mathematics was the source of all scientific truth. In mathematics, he said, the answers are always true. This was because mathematics began with a simple, observable principle and then used logic to gradually move to other truths. Today, Descartes is viewed as the founder of modern rationalism, the belief that reason is the chief source of all knowledge. What is the scientific method? Scientific thought also was influenced by the English thinker Francis Bacon, who lived from 1561 to 1626. Bacon believed that ideas based on tradition should be put aside. He developed the scientific method, an orderly way of collecting and analyzing evidence. It is still the process used by scientific research today. The scientific method is made up of several steps. First, a scientist must carefully observe the facts and then tries to find a hypothesis or an explanation through facts. Through experiments, the scientist then tests a hypothesis under all possible conditions to see if it is true. Finally, if repeated, experiments show the hypothesis is true, then it is considered a scientific law.